Lesson 5, equations and their graphs. We have a problem here. Suppose we're buying beans and rice to feed a large gathering of people, and we plan to spend $120 on the two ingredients. Exactly $120. Beans, X, cost $2 a pound, and rice, Y, costs 50 cents a pound. So we're going to fill in the coefficients here for this equation. So X stands for pounds of beans, and Y stands for pounds of rice. All right, so pause the video, see if you can come up with the equation. If you said, so we know the total is $120, $2 times the number of pounds of beans, 50 cents times the number of pounds of rice. So when we have an equation with two variables, so X and Y, those can be graphed on a coordinate plane. So here's our coordinate plane here. And we have the x-axis is how many pounds of beans. The y-axis is the number of pounds of rice that are purchased. And then this line represents this equation here. It's graphed on the line. And in subsequent lessons, we will learn how to graph equations like that. And so we'll talk about what that means here in a moment. So the first task for us is to write the coordinates, the ordered pair for each point, so points A, B, C, D, and E. Then test if the point is a solution to the equation. So let's do point A together. So the coordinates for point A, so coordinates on a graph are always listed with the x value first and then the y. And what that means is we start at the origin, and it's asking how many steps do we need to take in the x direction, and then how many do we need to go in the y direction to get to our point from the origin. Notice here on this graph that the x-axis, every square represents 10 pounds. And so I'm filling in the ones that are not written here, right? On the y-axis, however, it's a different scale. Every square represents 20 pounds. So to get to point A from the origin, I have to go over 10 and up 200. So point A, the coordinates are 10, 200. And in this problem, that means 10 pounds of beans are bought and 200 pounds of rice are purchased. So you can pause and now write the coordinates for each point. All right, now coming back, we are going to write see if they are solutions to the equation. So if something is a solution to equation, let's remember we have these notes earlier from lesson 4. The solution to an equation with two variables is an ordered pair that when substituted into the equation makes the equation true. So we're going to substitute this ordered pair, this is x, this is y, into our equation. So we're going to substitute 10 for x, and we're going to substitute 200 for y, and we're going to ask ourselves, question mark, does this equal 120? So 2 times 10 is 20, 0.5 times 200 is 100, 20 plus 100 does equal 120, so this is a solution, yes. So now go ahead and try this for all of the rest of the points. I'm going to write them on here for us. I would pause the video and try this on your own. Right, there's all the coordinates. Then we're going to plug them into the equation. Check and see if it makes the equation true. Work that all out. This one, 40 plus 40, does not equal 120. So that is not a solution. Let's try the next one. Is this a solution? Does that equal 120? This one, 2 times 45 is 90. 0.5 times 60 is 30. That does equal 120. That is a solution. 70 and 180. If I plug that in, I get on this side 140 plus 90. That does not equal 120. That is not a solution. This one, if I plug it in, I get 60 plus, 2 times 60 plus 0.5 times 0 equals 120. And that is 120 plus 0. That does equal 120. Yes. All right, so let's fill in a few more things. How about this? This graph shows a straight line, meaning it is a linear or nonlinear equation. Linear, it's a line. Now, looking at the graph, what do you notice about the points that are solutions? So we've determined that A is a solution. We've determined that B is not a solution. C is a solution. D is not a solution, and E is a solution. What do you notice? Well, the solutions, missing a word here, to equations in one variable lie on the graph of the equation. Okay, now we're going to, I think I corrected this in your notes, I have it wrong here. This should be negative 6x plus 4y equals 12. So now we have a different linear equation. And we're being asked to determine if each point lies on the graph of the equation. So we could graph the equation and then graph the points and see if they lie on there, and then we would know. But what I'd like you to do is determine it algebraically. And so we're going to use the same method we did above here, where we plugged in the points to see if they made the equation true. So let's try one together. So negative 4 is the x value, negative 5 is the y value, and we're going to plug it in to this equation, negative 6x plus 4y. So we'll say negative 6 times the x value, negative 4, plus 4 times negative 3. Does that equal 12? Oops, I wrote something wrong here. Should be negative 3. Okay, negative 6 times negative 4 is positive 24. 4 times negative 3 is negative 12. Does that equal 12? Well, 24 plus negative 12, remember when we're adding a negative number, that's the same as subtracting the number. 24 minus 12 does equal 12. So yes, this first one is a solution. All right, you pause the video, try the other ones on your own. And I'm just going to put the answer. For credit, you have to work it out on your own. You have to plug them in and write them. This one is not a solution. This one is also not a solution. And this one is a solution. And you show that in notes, and that is it.